Experiment 3. Resolution of matter into pure substances using fractional crystallization. We start with a mixture of silicon carbide, potassium nitrate, and copper sulfate. First we dissolve the mixture and then heat it up to make sure all the potassium nitrate and copper sulfate dissolve. The silicon carbide does not dissolve and stays as a solid, which can be separated by filtration. Using a Buchner funnel, we filter out the solid silicon carbide. The Buchner funnel filters with suction. In this case, the vacuum is caused by an aspirator. First, we wet the filter paper so it will seal to the funnel and none of the solid can pass through to the filtrate. Vacuum filtration goes faster because the vacuum pulls the filtrate through the filter paper and helps avoid the problem of the filter paper getting clogged by the solid. It helps the filtration to decant as much of the liquid portion as possible first, and then put the solid through the Buchner funnel. We are attempting to quantify the amount of each of the three components of the mixture, so we want to try and collect as much of the solid silicon carbide as possible. As a final step, we wash the silicon carbide to ensure that all the soluble potassium nitrate and copper sulfate is dissolved and washed into the filtrate. In order to speed the drying, we allow the vacuum to pull air through the solid. We then put the filter paper and the collected solid on the lab bench to complete the drying before quantifying the amount of solid collected. We weigh the solid after it is dry. We will now work with the filtrate to separate the potassium nitrate from the copper sulfate. We add nitric acid to help the copper sulfate stay in solution throughout the procedure of crystallization. We heat the solution to reduce the amount of solvent. Remember, from the solubility curve, we see the potassium nitrate is much more soluble at warm temperatures than copper sulfate, but at low temperatures, potassium nitrate is less soluble. Slowly, we begin to see a solid formed. The solid forms as the solution splashes up on the sides of the beaker and the solvent evaporates. We stop heating when the solution becomes cloudy because it is saturated with potassium nitrate. We add a little water to wash the potassium nitrate off the sides of the beaker and back into the solution. In a process called fractional crystallization, we cool the mixture so the potassium nitrate will begin to solidify, remembering that the solubility of potassium nitrate drops much faster than copper sulfate as the solution cools. Notice from the curve that if the solution is saturated at 100 degrees with potassium nitrate, when we cool it to 0, a lot will fall out of solution. We have designed the experiment so the solution is saturated with potassium nitrate, but not copper sulfate. Notice, however, some copper sulfate might also fall out of solution and contribute to the impurity of our sample. We filter out the solid precipitate using the Buchner funnel. We chill the Buchner funnel so that the potassium nitrate doesn't warm up enough to become more soluble in the water as it passes through the funnel. We again decant the liquid first and then add the solid to the Buchner funnel to dry. We use another piece of dry filter paper to squeeze out as much of the liquid as possible. We understand the solid is mostly potassium nitrate, but it also contains a little copper sulfate. We collect the solid for both testing and further purification. We use 0.5 grams for testing for purity. We dissolve the 0.5 gram sample and add ammonia. The ammonia forms a tetraamine complex with the copper 2+ ion to form the blue color. We are going to test for the amount of copper sulfate using a spectrophotometer. We will test at a wavelength of 630 nanometers. Before making our readings, we must zero the machine. With no cuvette in the holder, we set the transmission to 0 because the light is not on. With a blank cuvette in the holder, we set the transmission to 100 as all the light should go through. We measure the absorbance of our sample and compare it to a standard curve to determine the percent copper in our sample. We redissolve the remaining solid and begin cooling that sample to recrystallize the solution. A precipitate will form again, but of much greater purity than our first crystallization. The impurity, copper sulfate in this case, will remain in solution because it is more soluble than the potassium nitrate at the colder temperature. We then use the Spec 20 to again determine the purity, and we find that in fact our solid is much more pure potassium nitrate.